What's up, guys? Welcome back to LeetCode Path to Pro. Today is January 11th, 6:15 p.m. Yeah, it's kind of late. Yeah, I'm just gonna do one problem today. Only have time for one. Gonna keep going through these no's. I mean, if I'm doing one, God, this problem is. I hate that problem. Feels very domain specific. Could do the reorder list. Got a bunch of no's down here. Bunch of true problems. That's the matrix. I can crush those now though. Rotating, which might be a little tough, but it's doable. But some strings stuff. What's that? How did I not get this one this easy? Oh, I think I remember this one. It's really frustrating. Just have to clean it a certain way. Yeah. Alright, but I think I'll just go ahead and do the other linked list problem. It's definitely tough. Tough problem. Alright, reorder list. Number 143. So you are given the head listing linked list. Excuse me. This list can be represented as not modified value. Okay, so basically the idea for this is basically you want to find the midpoint. What you're doing here is you're weaving a linked list together. So you have a linked list like 1, 2, 3, 4, 5, and then you want to weave it so that it goes 1, and then 5, and then 2, and then 4, and then 3. And you can see just from me drawing there, I like kind of went, oh jeez. Sorry, Google Chrome, I keep like, you can see I like went 1 to 5, then 5 to 2, then 2 to 4, then 4 to 3. So like it goes in a circular, there's like a pattern there, but we're like weaving these elements together. And you can kind of think of these as like, so basically the intuition is you split the linked list in two, you reverse the back half of the linked list, and then you just weave back and forth. Yeah, so that's what we're going to attempt to do. That's the logic. I mean, it's pretty straightforward. I mean, it's just like 3 steps, you know, find midpoint, well, 4 I guess. Find midpoint, which is, I mean, its own LeetCode problem, I think. Find midpoint, you know, reverse the second half of the linked list, and then weave them together. So I guess it's 3 steps. So it's not, but you know, it's not necessarily like those 3 steps are easy to do. You know, you have to know how to do all 3 of those. So all fast next, slow equals slow dot next. Next dot next. So now, this problem's pretty hard. So now, our slow should be, because I reset slow. I downloaded like a drawing application a while ago. I have no idea how to pull it up. Okay. I like bought it as well. It's like $4. Yeah, I don't know. Can a neural network? Oh, that's pretty cool. Yeah, I don't know where it is, but let's just try to go with the noggin, you know? Give it a shot. And then we want to set slowdown next to that, right? We want to disconnect this from, well, that's after temp. Right, we want to disconnect this from the, we want to disconnect this first and second half, otherwise. And then, what do we want to do? So we want to reverse the second half, so like while temp. For so we want to set temp. We need a previous as well. Right? We just said here. Or yeah. So before is this. Let's just say there's 6 in it. So then for temp will equal, this will be temp, this will be 4. Or we don't want to change that. Yes, we need 2 pointers. So we're setting it to 1 before. But I guess we don't need to set this, right? So the temp to be this. So 4 equals temp done next, which is null, because it's default null. And then, so before is like here. temp is here of current. Right, for right there next, then current dot next equals after, and then after equals current. We also need to set the after dot next. Right, because right now what's going to happen is slow is here, current is here, after is here. We set slow dot next to none, disconnect, effective, boom, done. Then we set for to be none over here. Current dot next equals after. And then maybe we just want to do this the one time, right? Yeah. And then after equals current, and then current equals before. And then we say while n1 n2 equals. And at the end of all this, our after will be at the end. We get the final node on the records. We can say like while n1 do we need more pointers? Because we need pointers. Right, like temp1 equals n1 dot next. N2 equals N2 then next, something like this. And we say like N1 dot next equals N2, N2 dot next equals temp1, right? So when you reversed, I'm just like, you should really draw all this out, but I'm just going free because I don't have time. So this is assuming we have a list like 1, 2, 3, we have another list like 5 and 4 reversed. So N1's here, N2's here, temp2's here, temp1's here, N1 dot next equals N2, yes. And then N2 dot next we want to be here. Temp1, yeah. And then we want N1 here, N2 here. Yeah, that's all we need to do. So N1 at 2. See if this works. It's a lot of code. Okay, clearly not. Should we go check it? Yeah. Well, I mean, doing a lot of good stuff here. Next. Damn, so this code is like, wow, okay, I'm impressed with myself. I mean, I know it's only 6 days since I do this, but it's working. Yeah, I mean, we're just doing this. This is the trickiest part, I feel like, right here. This is the trickiest part, right? Setting these. It's the part that's trickiest for me. So that's doing that next and next. I would just set after to none. Why does that work? Well, current before equals current next. Current dot next equals after because we just said after the none. We just create a none dummy node, basically. Alright, just pointer. Alright, let's go. Well, current. After equals. Yeah. So you're not, we want to check one too. Because I mean, that makes sense because that'll be the one that terminates first. Right. Okay. Yeah. Definitely need like one more run at this problem. So I mean, the space complexity of this is O1, which using pointers. Time, a little trickier. I mean, but we're looping through everything with that. I think it's just O of n, right? Because it's like we're doing O of n, an O of n operation multiple times, but that's still, constant number of times you're doing O of n. So we're doing O of n here, doing O of n divided by 2 here, we're doing O of n here. So I mean, it's, O of n plus O of n plus O of n divided by 2, O of 2n divided by 2, or that's not how you would add that. O of 2.2.5 n divided by 2, right? 2n plus 2n plus, which is, well, and you can see, look, it's a constant graph. So I think it kind of tells you, it's kind of cool. Or not constant here, but it's constant. Linear time, sorry, it's a linear graph. Oh, I didn't do that. N plus n, that's should be, yeah, 2.5n, yeah. Tripping. So it's 2.5n, but I mean that doesn't matter. We drop that multiplication because it doesn't really matter. I mean, in real life, it probably definitely matters, but in case of the theoretical time, that's the only you say. Done a lot of these. Cool. Yeah, I mean that's it for me. Might keep it or no, but I don't know. 2 pointers. Jumping gun. Put that in there. That'll help. All right, cool. See you guys. Have a good, happy Friday. Have a good Friday.